Okay folks, in this video we're looking at rationalizing the denominator involving surds. So rationalizing here when we have one number on the bottom and when we have two numbers on the bottom, okay, in this video lesson. Okay, so if you want to pause the video, okay, have a go at the questions if you're comfortable, and then come back and press play if you're ready. Okay, if not, that's fine. Watch it in full and take any appropriate notes, and I'll try to go through them here quite slowly in detailed explanation in my answers. So 16a, rationalize the denominator of 22 over root 11, give your answer in its simplest form. Now what does rationalizing the denominator actually mean? It means to get rid of the surd that is on the bottom of our fraction, i.e. our denominator. Now we do this by multiplying the fraction by 1, but we rewrite 1 as, in this case, times root 11 over root 11. Okay, so anything over itself is equal to 1. So I've not actually changed the fraction. Okay, so all I'm doing is multiplying this fraction by 1, but I'm expressing 1 as root 11 over itself, because any number or term divided by itself will always give me 1. Okay, so yeah, okay, and you'll see why I'm doing that in just a second. Okay, on the top, so I'm multiplying fractions. I multiply top by top and bottom by bottom. 22 times root 11, I write it as 22 lots of root 11, so 22 root 11. And on the bottom, here's where the magic happens. Root 11 times root 11 is just 11. Okay, hence I've now rationalized the denominator. I've gotten rid of that surd on the bottom by doing this process. I can now simplify this here, divide top and bottom by 11. We get 2 root 11 as our final answer, because 22 divided by 11 makes 2, and then we obviously tag on the root 11. Okay, so the other key property, guys, or the key rule, is that numbers go with numbers and surds go with surds. Okay, so number on the outside goes to number on the outside, and the number on the inside goes to number on the inside. Okay, so that's part A done. What about part B? Okay, a bit more trickier. So that root 3 all over 2 root 3 minus 1 can be written in the form A plus root 3 all over B, where A and B are integers, meaning whole numbers. So here I'm going to do something here slightly similar, but a little bit different. Okay, so I'm going to multiply top and bottom this time by the conjugate of the denominator, i.e. the same, but I'm going to switch that minus sign in the middle to a plus sign. Okay, and again, you'll see why I'm doing that, okay, in just a second. Okay, but hopefully you can see here that I'm going to create dots on the bottom, so difference of 2 squares on the bottom. Hence, this is how I'm going to rationalize the denominator. Okay, so you hear me say the word dots a lot in maths. Dots just means difference of 2 squares, i.e. a squared minus b squared factorizes into a plus b times a minus b. Okay, so multiplying fractions, multiply top by top, bottom by bottom. Root 3 times 2 root 3, or root 3 times root 3 is just 3, times it by 2 and I get 6. Okay, and root 3 times positive 1 makes plus root 3. So far so good on the top, okay, because it is in that kind of format. And on the bottom, okay, we're going to do 2 root 3 times 2 root 3. Well, 2 times 2 is 4. Then I have root 3 times root 3, which is just root 9, which is just going to be just 3. So 4 times 3 there. Then I'm going to have 2 root 3 times positive 1 makes positive or plus 2 lots of root 3. Oops, sorry guys, apologies about that. Okay. Then I have minus 1 times 2 root 3 makes minus 2 lots of root 3. And then finally, I'm going to have minus 1 times plus 1. So minus 1 times positive 1 makes minus 1 or negative 1. Okay, for that. all I do now is just simplify. So 2 root 3 minus 2 root 3, they're going to cancel, hence eliminating the third on the bottom. On the bottom, I'm now going to have, so I'm going to copy down here, the 6 plus root 3 on the top. On the bottom, guys, I'm going to have 4 times 3 is 12. Then I'm going to minus 1, I get 11. So my final answer reads 6 plus root 3 all over 11, or an 11th brackets 6 plus root 3. Either answer would suffice, but now that's in that format where in this case A is equal to 6 and B is equal to 11. Okay, you don't actually have to state that, but I'm just putting it in there just to be clear that you're happy that it's in this format. Okay, and that, guys, is how we rationalize the denominator, okay, of a fraction. Okay, we multiply top and bottom by 1, but we rewrite 1 as the denominator in some cases, or the conjugate of the denominator here when we have more than one number on the bottom, okay, with a third. But yeah, that's pretty much it, guys. And again, this is a topic that's guaranteed to come up on your higher tier Edexcel, AQA and OCR past papers, and also IGCSE papers, okay, for your non-calculator papers. So you can't afford to get these wrong in the exam, okay. So yeah, if you're aiming for grades 5, 6, 7, 8, or even grade 9, you cannot afford to get these questions wrong, okay? Thank you for watching.